Today we have a new engineer here at Anant, Isaac. He's going to be presenting on the basics of Cassandra. The co-organizers and organizers for this event are Rahul Singh, Arpan Patel, and myself. And we are always looking to find new members and sponsors as well as speakers. If this is something you'd be interested in doing, either spreading the word, getting more people to join, or if there's some specific technology surrounding Cassandra that you would like to learn and present on, definitely go ahead and reach out to us. Our emails are listed there at the bottom. So always open to hearing more from the community and having more of you guys speak here. We are a part of a larger community, Data Community DC. We do believe in a diverse culture, and we support and encourage people of all races, genders, sexual orientation, religion, anything like that is welcome here. And we expect respect to be given to those protected classes. You can find out more about Data Community DC at their blog listed here, as well as some more upcoming events. And what we cover here is everything related to Cassandra and Cassandra's ecosystem. So this includes data stacks, which is kind of the enterprise version of Cassandra, but also we cover things like Spark, Kafka. We've done Grafana dashboard. So pretty much anything surrounding Cassandra or interacts with Cassandra is open game to speak about here. And we have plenty of talks on YouTube. I see we have a lot of new faces here. If anyone would like to unmute themselves and kind of share what they do about or with Cassandra, or what they hope to learn today, what they're interested in about Cassandra, feel free to do so. I won't pull any teeth. We can keep moving on. Group rules: if you have a question, please ask it. Be polite and courteous to others and share what you know. This is meant to be a discussion. Isaac, you can go over your ground rules of how you would like questions to be asked. Some speakers are fine with it in the chat at any time. Some have dedicated portions of their presentations in which they like questions to be asked. Here at Anant, we connect real-time data platforms for our clients. We architect them. So Cassandra is something that we work with quite frequently as a real-time data solution. DataStax is also a partner in this. We've actually just concluded a 3-part workshop with them that was occurring every Tuesday. Those are now on YouTube, I believe. Unfortunately, if you missed the live event, today or Tuesday was our last one. George Washington University used to support in-person meetups. Hopefully we can get back to that. And we're always looking for more sponsors, as I mentioned before, so you could get your company shouted out here as well. Also, some of the organizational sponsors to Data Community DC. And at this point, if anyone has any jobs, meetups, or hackathons that they would like to promote, you can unmute yourself, share your video, and go ahead and promote whatever you may have coming up. I will take that as a no. One of our announcements is we are hiring for full-time or part-time positions at data platform operator, engineer, or architect. You can find out more at careers.anant.us. Some upcoming events that we have, going to be creating a user profile using DataStax Astra. I'll be giving that discussion with a React front end, as well as Databricks and Cassandra. We do have a sister lunch to this. Data Engineers Lunch occurs every Monday, same time, well, different link. So, but every Monday at noon as well, Eastern time. And you can find all of our events listed at anant.us/events. Also, as I kind of mentioned briefly before, all these videos are recorded and uploaded to YouTube, where we are actually also live streaming now as well. So you can check us out on YouTube. If there's any sort of past topics you'd be interested in, that's a great place to look to see. Maybe we've likely already talked about it. This is the 70th edition of Cassandra Lunch. So we have a lot of content on YouTube. As well as be sure to check out Cassandra.Link. These are all hand-curated articles by Raul Singh here at Anant. And this should be your first go-to place if you are ever trying to do something new or learn something more about Cassandra. Definitely check out Cassandra.Link first. There's just tons of content and articles here. You can see everything from Cassandra to Kafka. It's a really great resource if you ever need to learn something about Cassandra. So with that, I will pass it off to Isaac to begin his presentation.
Thank you, Josh. So, can you see my screen?
Yeah, I can see it.
Okay, thanks. So I want to greet everybody. Welcome to today's Cassandra Lunch. So my name is Isaac Omalayo. You can call me Isaac, and I'm a junior software engineer at Anant. So today I'm going to be taking you Apache Cassandra. So we're going to learn how Apache Cassandra is very, very important. So just to give you a brief introduction about myself, I like working with data problems. I like working with REST APIs, anything that deals with data engineering, airflow, streaming, and all that. So data engineering is my passion. So I hope everybody is going to learn a new thing here today. So just for you to go through the list of things we're going to learn today. So we're going to learn what is Apache Cassandra. We're going to see why do we need Apache Cassandra, and we're also going to look at features of Cassandra. And at the end of the day, we're going to try to we're going to install Apache Cassandra. So we're going to look at the installation guide, and we're going to write into the database we've created. So yeah. So what is Apache Cassandra? So Apache Cassandra is a fast distributed database that is built for high availability, and is actually built for linear scalability. So you have the ability to scale as your workload is increasing, and that is one of the strengths of Apache Cassandra. So the idea behind the Apache Cassandra is that there should not be a single point of failure. So when you connect your big data application to the database, there must not be a point whereby your application should go down. Your users should be able to query your database, and they are able to have access to their data at the right time, anytime, 24/7, right? So that's the idea behind Apache Cassandra. And interestingly, Apache Cassandra does not have slave or master relationship. So every of the nodes that runs Apache Cassandra is designed the same way. So we're going to look at how this come together in a few moments. So Apache Cassandra, the replication, when we're dealing with distributed systems, the most important thing is we want to make sure that your data is distributed in every location, so that any of your users, they can have access to the database. Okay, And the Apache Cassandra replicates your data automatically. Okay, so we're still going to look at this. Yeah, so interestingly, if you are coming from a relational background, say for example, you'll be working with different databases like MySQL, like the Microsoft SQL Server, you find out that you're going to be using the SQL, that's the structured query language, to communicate with your database. So in the same way that we have the SQL, we have CQL for Apache Cassandra. So that's your query language that you're going to be using to do data divination, do data manipulation, DDL, and all that. So the SQL is your query language, right? So someone might want to ask me that why do we need Apache Cassandra? And the most important, interesting reason is that Apache Cassandra is an open source. So that means you can have Apache Cassandra sitting in your garage, and you can have it installed on your computer somewhere at the corner of your house. And what you just do is you dump your data, some important files, your data inside Apache Cassandra. So it's an open source and it is affordable. Okay, so you can easily extend your application to Apache Cassandra. So interestingly, many companies are adopting Apache Cassandra. So companies like Netflix, Apple, and Discord, different companies are going straight to Apache Cassandra, and it's just because they found out that look, Cassandra, it looks like Cassandra can give us what we want. So, and it's elastic. So it's elastic in nature. What we mean by that is you can easily scale the storage facility. Probably you find out that your database is getting low of space. You want to increase the computing functionality. You can easily do that, okay, with the help of the commodity hardware. So you have the ability to contain costs, okay, when it comes to Apache Cassandra. So it's highly available. So the nature is that your data should be decentralized, should be distributed across various locations. Okay, so so that there will not be a single point of failure, right? So yeah. So and very, 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 very important, Cassandra is very easy to manage. So say for example, you have an organization whereby you just have 3 persons, that are data guys. Okay, you can easily take them into a team, and they'll be able to manage your database. So it's very easy to manage, and you can handle structured and unstructured data. It's Apache Cassandra. So if you are coming from a relational database, you find out that there is a very, very high priority for ACID compliance when it comes to relational database. So interestingly, Apache Cassandra supports that. Okay, so and if you have not worked with any database before, if you are not worked with Apache Cassandra or any database before, don't worry. This class is for you, right? So now let's look at the design architecture of Cassandra, because we've been talking about this database is actually very effective. Okay, so let's look at the design architecture. And the design architecture, just like what I said there's no slave or master relationship. So every of the node, I want you to see it in such a way that everybody is the same. Okay, everybody is the same. There's no master, there's no slave. So you can decide to give any of the nodes a particular workload, and they're going to deliver, right? So I want you to look at this diagram that I have here. So this diagram is showing the cluster, is showing the data center relationship. Don't worry, but I haven't heard about cluster before. So cluster is I wanted to understand that cluster is a combination of data centers. Okay, so just like that's the reason why I have it in hierarchy in here. So cluster is a combination of data centers. Data center is a combination of racks. So in a rack, you can have multiple servers. In a server, you can have multiple nodes. Okay. So, and in data center, you can have multiple racks. You can decide to design your data center that does not have a rack and just have nodes. Okay, bunch of nodes. All right. So, and you can have multiple clusters. But at the right hand side here, we have just a single cluster. So, and for this cluster, we have 4 data centers. Okay, so we have one in EU, we have one in North America, we have one in Asia Pacific, we have another one in Africa. So these data centers, they have the advantages. Okay, so and the advantages is that we want to make sure that our data is available to everyone. Okay, so everybody that is trying to access our big data application from any part of the world should be able to have access to all the data at the right time. You know, there should not be latency. Okay, so so I wanted to look at inside the box, the data center box. So I designed a rack. I designed 4 racks in here. So for the Europe data center, we have 4 racks, and you know, so in a rack, you can have multiple nodes, you know, just like based on your use case, based on your application, right? So in here we have 4 racks. Okay, don't worry, I'm still going to show you. I'm still going to tell you why we have the design like this. Okay, but basically I want you to understand that inside this cluster you have multiple data centers. Inside the data center you have racks. Okay, cool. Now let's look at the CAP theorem. So in the CAP theorem was proposed by one of the computer scientists and called Breuer's theorem. So he proposed that before you can say you are fine with your distributed system, then the system must be consistent, it must be available, and partition. So he now take a step forward and say that you cannot achieve these 3 characteristics for your distributed system. So you have to trade off one of the characteristics. Probably you want to trade off consistency, you want to trade it off for the availability and partition tolerance. So what we mean by that is your database, you want your database to be available at all time, and you don't want your database to have any single point of failure. So you don't want any single point of failure. So with that, you're going to trade off the consistency, or probably you want your database to be consistent and available at all time. So you trade off partition. So that's why it's saying that you cannot get that. Okay. So, but interestingly, what Cassandra does is Cassandra gives you the ability to give you availability. It gives you partition tolerance. So that do you have any question? Okay, I think we're good. Right. So I was thinking we have a question. So we have consistency level, we have consistency, we have availability, and we have partition. All right. So I want you to focus on this diagram. At this left-hand side, we have the availability, we have the partition, we have the consistency. So you are going to trade off one. Okay, so but Cassandra gives us this ability to tune the consistency. Say, for example, I'm building my big data application. I want my big data application to be available at all time, and I don't want my users to query my database, to query my application, and they will not have access to it. So I'll make sure that the application is available, okay, and it is partition tolerance, okay. So no single point of failure. So the consistency, Cassandra gives us the ability to tune this consistency. That means you want to have your database to be 60% consistent, you want it to be 50% consistent, you want to be 80% consistent. So you are at liberty to do all that, okay. So say, for example, if your data center if one of the, or probably two nodes or two nodes of the racks just goes down, not America data center. So in here, the Cassandra still gives you the ability to run your application on the other parts of the nodes and all that. So in fact, your users, they will not know that something has gone wrong. You know, everything is still working perfectly fine. So in a situation of, say, for example, Netflix is trying to make sure that a movie is available to everybody in the world. They design data center at different parts of the world, and they replicate the data. Okay, they replicate the data to all the data centers, so that even if you access the data from South Africa, you access the data from China, you still be able to connect to your movie, even with the nodes going down, and they are down already. So that's the availability characteristics of Cassandra. Okay, so yeah, let's look at this. So in here, I designed 4 nodes in a rack, and what I'm doing here is I'm sending what I'm doing here is I'm sending a request to all the to 3 nodes. Okay, so what is happening in here is that there's a communication between all the nodes in a rack in a data center. Okay, so the nodes, they are connected together, right? So if one should go down, the other nodes knows that this is down, okay, and they pick it up, they pick all the workloads for the other ones, and they accommodate that that downtime, okay, by themselves. So look at this. I said all nodes in Cassandra communicate with each other through a peer-to-peer communication protocol called gossiping. So they gossip with themselves, they know the needs, health, they know when the data is coming in, just like they gossip together and to share information, right? So if one of these nodes should go down, then you still have ability to your data, okay? So that's when you have the ability to tune. Say, for example, you want to be able to you want to be able to have your 2 or more nodes, okay, giving you a confirmation that, okay, we got your data. You might decide to give it 2 consistency level. You might decide to say, okay, I want 50% of my nodes should give me a response that we have our data. So this is all together, and the way this is designed is just to accommodate availability, to make sure that there's a fault tolerance, and every of your application runs perfectly fine, right? So now I don't want to bore you too much with theory, because I want us to install Apache Cassandra and look at how things are working in there. So There are different ways you can install Cassandra. You can decide to install it using Docker desktop if you are using Mac and Windows. You can decide to install it using tarball, binary, package installation with the Linux type. So, but the most important thing I want you to notice when you are deploying Cassandra, the production level, make sure you always use your Kubernetes. That's the recommended way to push out your database into production. That's the recommended way for Cassandra, because you don't want things to go down, and you want your database to be able to scale up. It's with everything working perfectly fine. All right. So I will not install using the tarball binary file. I will not install using the package installation. I will install using the Docker, right? So at the end of the day, after we've installed it, we're going to write into the database, and we're going to create key spaces. Don't worry, if you don't know anything about key spaces, I'm going to explain this thing to you as we get along. So we're going to create tables, and we're going to write into the tables, okay? So, okay, cool. So before we start the demo, do I have any question at this point? Okay, I want to take that as a no, and that means we're cool, right? So what we have in the first list is we have set up Cassandra using Docker, right? So I'm just going to go to my browser. So if you want to install Docker, first of all, make sure you install Docker desktop. Right? So just say download Windows. Okay, so it's going to take you to the first link, and on the first link, just follow it. Make sure you download and you install Docker Compose. Okay, so when you download and install Docker Compose, run it and make sure you install it. Now, what you're going to do is after you start up your Docker, so you're going to have something like this. Right, so it's going to be blank. Don't worry, I am running some containers here. Don't worry. So the way the Docker Compose works is you're going to use it to pull different images from different images that you want, which actually makes things very easy for you for the installation. Okay, so the way we're going to pull the image we want. So we're going to be working with the Cassandra. So Cassandra has the images, right? So on the Docker Hub. So this is the command to pull. So I'm just going to say, I want to confirm my Docker desktop is running. So I'm just going to say Docker PS. And as you can see, we have Cassandra running here. But if you don't have it, there's no problem. What you just need to do is just say Docker pull. You're going to say you want to pull the Cassandra image. Then you want to pull the latest version. Okay, I'm not going to hit enter because I already have it. So I already have the image. So when you do that, you do a Docker run. You run your the name of the database. Probably you give it a, let's just say demo. I'm using that name as demo. Cassandra, the latest, that's the name. Then you hit your enter. You hit your enter. So if this demo does not work, you can take it up from the ID. So you can also run using the ID, right? So and you have access to your container. Okay, so how it works is you take it from images to the container, right? So Then after you have your container running, then you can now go into the container by saying docker execute -it. I'm going to use the ID to go in here. So I'm just going to say bin bash. So I'm just going to go into the bin bash, I'll hit my enter, and I'm inside my Cassandra container, right? So in here, I just like ls, I don't know why. So I'm listing the directory in the container, right? So what we want to do here is we want to start playing around with the Cassandra database. Okay, so don't forget what I said. I said we have key spaces. Key spaces is just like your database, okay, in the relational world, relational database world, and the database, the tables, is still the same thing with what you have in the relational world. So it's very, very easy. So we're going to go into our database and start communicating with the database. So what we're going to do is we're going to say SQL shell. So we're going to access the SQL shell. Okay, so that's where that's our platform. That's the interactive environment where we're going to be writing our Cassandra query language. All right, so I'm just going to hit enter, and in here we're here. So we have our database running at 127.0.0.1 colon 9042. All right. So now this is where we can say, okay, say for example, I want to list all the database, all the key spaces in my Cassandra. So I'm just going to say describe, okay, key spaces. Yeah, so I have some of those key spaces are there already. So these key spaces are the ones that comes with Cassandra. They helps in running the database itself. Okay, so don't forget what I said that we're going to do. So we're going to create a database, and let's just create a database. So if you want to create a database, that's when you're going to define the replication factor. You want to define how your database will be available in all over the world. Okay, so in here we're going to create a database and say, okay, I'm just going to say key space. If not exist, okay, so, and the database name I want to create is, I want to say voting underscore system. So we want to create a simple voting system so that people in all over the world can easily vote. They can vote into our voting system. So, say for example, they are trying to know the they want to know the highest number of views, okay, for a movie. Okay, so they want to vote. All right, so say we're just going to have something like so here we're going to define our replication. So we're going to say replication. We're going to define our replication strategy. Say strategy. We're going to have K class. So we want to have simple strategy. Okay. All right. So yeah, cool. So we're going to have we're going to include the replication factor as well. Okay, and so in here we are giving it replication 1. So what this means is, let's take it very slow at a little bit at this point. So in here we're creating our key spaces, and we are saying that if this voting system does not exist before now, then replicate this data based on the simple strategy, class. Okay, so this simple strategy is recommended for development. Okay, but when you are going into the production, always make sure that you use the network topology strategy. Okay, then we're giving it a replication factor of 1. So that means that in our database, this data is only going to be replicated once. So, and why we are doing this is because we're only working with a single node. So in a situation whereby you're working with multiple nodes, multiple data centers, you're going to define this replication factor, probably 3 or 2 or 1, or don't use 1. I'm just saying. You might want to use like 5, depending on your use case. Okay, and the purpose of this is when you replicate your data in different nodes, so that they can be accessible at any time. So that's the reason. Okay, cool. So we're going to have this. So I'm just going to give it 1, and I'm going to create this. And okay, let's describe and see. Okay, our voting system is here. So what we're going to do is we're going to use these key spaces. So I'm just going to say use voting system, and okay, good. So we're in the database now. So what we need to do now is start creating our tables. Okay, so you can create 10,000 tables. I'm just saying. So you might want to create like 4 tables in your database, in your key spaces. So it depends, it's up to you. So we're just going to create a table. So we're going to say we're going to create a table for our voters. So say, for example, our voters are trying to vote from Netherlands. So you can easily say create, okay, table, if not exist, then create voting. Okay, create it in a voting system. I'm just going to say the name of my table is voters. Okay, so now what I'm going to do is I'm going to start defining my column, my column name. So I'm just going to say I need my voters ID, voters ID. Okay, so the type of data that I want to bring into the voters ID is that I want it to be UUID. So I want it to have a unique identifier. I want to have the time each voters. Okay, so I'm just going to say timestamp. Okay, so that's the data type of that column. So I'm going to enter the name of the voter is going to be text. The name of the person is going to be text. The city of the data, the city of the voter is going to be text as well. I'm going to have the state. I'm supposed to have country, but don't worry, we're just going to continue with this. We're not going to include country. So, okay, so let me stop a little bit at that point. So, as soon as you created your database, your table, make sure you include all the columns you want to include beforehand. So, in the production, you'll not be able to alter and just bring things down. You'll not be able to do that. I'm sorry. So, so let's just bring in the supporting column. So this supporting column is going to be the person they are voting for. Okay, say for example, they want to vote for me. Okay, I'm just joking actually. So so we're going to bring in our primary key. So the primary key is used to sort your data, okay, to partition your data. So the partitioning in such a way that don't forget what I said. I said the replication factor is always going to be you're going to replicate your data. So but when you replicate your data, you want to partition that table in such a way that some set of rows, you find them in the nodes. So some set of rows, you find them in some other parts of your nodes. So your table is not just going to go into a single node. No, they are going to be distributed across your architecture so that when someone is trying to access a particular row, yeah, it's going to be very much faster. Just pick it up from there and take it back to the user. Okay, so that's how it is. So the way that is done, the way the method that allows us to distribute this data is using the the partition key. Okay, and the partition key and the clustering key is what makes up your primary key. So we are defining our primary key here. You might decide not to have a clustering column, but it's very, very important that you have your partition column. So that's very, very important. Okay, so we're going to have primary key. We're going to bring in the voter's ID. So we want the voter's ID to be the unique identifier for the table. So we're just going to say voter's ID. That's going to be my unique guy in there. So we want to bring in the clustering column. So we want to use the name as a clustering column. So I'm just going to bring in name. Okay, I'm going to close this. And don't forget this bracket that we opened earlier. So I'm just going to close this at the same time. Then we're going to have no. Okay, this is okay. Yeah, we're good. So I'm going to give it semicolon. So let's select star. So select asterisk is for all the tables. So we're just going to say select star from voting system dot voters. Okay, so okay, good. So this is our table. You can see that we have 0 rows. So we're just going to start writing into the table. So when we're writing into the table, we're just going to say insert into, we're just going to define the name of the database and the table, okay, and the values we want to write into our table. So we're just going to say voting system dot voters. Yeah. So in here, we're going to bring in the voters. Okay. We have the voters ID. We have the voter time, the time. We have the name. We have the city. We have the state. We have the supporting. Yeah. So they are supporting who are they supporting? Okay, good. So we are fine here. So we're going to insert the values. Yeah. So if I want to insert my values, I'm going to bring in the UUID. Okay, so the UUID by default is going to give it a unique identifier. We're also going to bring in the time function. Okay, time function called stamp. Okay, so it's going to timestamp it as the data is coming in, gives it the unique time for when data comes in. So we're going to have this. I'm going to take this down. Okay, let's insert Jackson, Jackson, right? And I'm going to have, okay, let's bring in Bradford. So just going to say Bradford, sorry. So we're going to bring in the name of so the state is California. Let's bring in California. Okay, sorry. All right, so yeah, so in here we're going to have, say for example, so that person, the name of the person called Jackson is voting for A. I'm just using A. Yeah, so followed by colon. Now let's select star. Okay, I think I have it before now, so I'm just going to select this. Yeah, so you can see that we have Jackson, we have Bradford, we have California, A, and this is the timestamp. I think this time is correct. That's the time that we have right now. So yeah, so I'm just going to let's just write one more. So let's write bond. Let's bring in bond. So I'm going to bring in bond. Okay, let's bring in the city name is Jasper. The state is Arizona. Okay, and this person voted for B. So just gonna click. So let's select star. Yeah, so we can go on and on and on and on. So for example, if you want to connect this to your database, okay, to your application, what you're going to do mostly is you're going to use API. So Stefan talked about the Stargate API, which I actually like the idea. So you can use the Stargate API, which is more matured, and as soon as data is coming in from an application, it goes straight to the database. So yeah, so I want to believe that okay, it's like okay, okay, okay. Oh no, 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 no. Okay, okay, cool. I like that. Thanks, thanks. Do I have any question at this point? I want to be sure that all the answers has been answered. Okay, good, 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 good. Okay, yeah, exactly, exactly. Yeah, it's possible. Say for example, you want to say for example, you want to write a null field. Say for example, you are trying to insert a column. You're trying to insert a column in here, but you didn't include the column. Say for example, you have Jackson. I want to use, okay, let's use Bob. Let's use Bob. The Bob is from Nashville, okay, which is from let's just say New York, Okay, so now if I didn't give vote for anyone, let's see what Cassandra is going to do. Okay, so you can see that it's stated that this thing is bad. Okay, so I'm just going to give it two code like this. Now let's see what is going to happen on our table. So I'm just going to select star. So you can see that nothing is showing there. So I don't know if I've asked her a question. Okay. Okay, so yeah, so with this, I want to believe that we've learned a lot today. And someone might want to ask me that, what if they want to query the database? Say, for example, they want to select based on the clustering, the partition column. Because how it works in Cassandra is, Cassandra does not want you to do a select star. So if you are doing a select star in a database that has a lot of data, that's not good enough. So what you're always going to do is you're going to always use your partition column to query your data. So for example, we partitioned our table using the voter ID. So if you want to query this, you're going to say where the voter ID, okay, equals the I'm just going to pick this up, and okay, I'm going to execute this. So because if you try to do this on 10 million rule of record, trust me, your query might spend the whole day, because the tables is going to be very, very much. So don't try to do that. So you filter, and you can include your clustering column and say where the name is equal to Jackson, so that Cassandra knows the exact place to give you return your data. Okay, so yeah. So, okay, I understand what is going on here. So you can see that it does not return any row, and it's just because I interswitched this. So I picked this, and I picked this. So I'm just going to take this back and say Bob. Okay. Yeah, so that will be all for me today. I will need to pass the mic to Josh. You can see that we've exhausted a lot of time. So Josh, you have the floor.
All right. Sorry, excuse me, you guys. I was just responding to Vanzy's question. There is an alter key space command in which you can change class and replication factors. The not null, what I found, it doesn't seem, I don't know if OB has a better answer, but it doesn't seem like Cassandra supports a not null column, like enforcing that data actually exists in an insert statement. It will just not add something if there isn't, kind of like Isaac demonstrated. I could be wrong on that, but from what I was reading into and looking into that question, that's what I found. But that is the end of our time. Thank you everyone for joining us today. Again, we'll have this again, same time, same place next week. If you want to watch me, I'll be presenting on how to create a user profile on a React client and then support it on the back end by Cassandra. But yeah, thanks again, guys, for joining. And thank you, Isaac. That was a good presentation.
Yeah, thank you.